ಮಿಕ್ಸ್ ಮಾಡ್ಬಿಟ್ರೆ ಮಸಾಲೆ ಪೂರಿ ಎಲ್ಲ ಸಪ್ರೇಟ್.
पुष्पा मैम।
Yes,
पुष्पा
ma'am.
मैम।
Yes,
हाँ,
ma'am.
ஓகேவா மேம் இன்னைக்கு?
ஜீவா மேம் சொல்லுங்க.
வியூ இருக்கா ஜீவா மேம்?
சொல்லுங்கப்பா.
ஜீவா மேம்?
கரெக்டா தான் இருக்கு.
சரி, ஓகே.
இன்னைக்கு கரெக்டா தான் இருக்குது.
ஓகே ஓகே.
ஓகே தான் மேம். எஸ் எஸ்.
ஓகேப்பா.
Ma'am, good evening, ma'am.
Sir, good evening, sir.
Good evening, sir.
Okay, ma'am.
Good evening, sir.
Welcome you, sir.
Thank you, ma'am. Thank you, ma'am.
Pushpa ma'am, it's time to start. Shall we start, ma?
Ma'am, please wait just 2 minutes, ma'am. Now 68 participants only.
Okay. Dr. Karupaya, sir, shall we start, sir?
Yes, ma'am. Fine.
Okay. Good evening to one and all present here. It gives me immense pleasure to welcome you all to the day 4 session of the 5-day International Online Faculty Development Program on Innovative Applications of Mathematics in Real-World Challenges. This FDP is being organized to bring together academicians, researchers, and experts to share knowledge and explore the versatile applications of mathematics in solving real-world problems. To begin the proceedings, I now invite Mrs. P. Nandini to deliver the welcome address and to introduce today's distinguished resource person, Dr. Karupaya Kannappan, sir, Assistant Professor, Department of Mathematics, Government College of Engineering, Bodinayakkanur, who will enlighten us on the topic applications of differential equations. The section is yours, ma'am. Please.
Thank you, ma'am.
Yes.
Good evening, everyone. It's my privilege to introduce our distinguished chief guest for today's faculty development program, Dr. Karupaya Kannappan, a highly accomplished mathematician, dedicated teacher, and inspiring researcher. Dr. Karupaya sir is currently working as an assistant professor in the Department of Mathematics at the Government College of Engineering, Bodinayakkanur, Tamil Nadu. His doctoral research focused on inverse problems of certain partial differential and integral differential equations, a sophisticated and impactful area of mathematical research. His research interest covers a broad spectrum and advanced mathematics, including inverse problems, partial and ordinary differential equations, control theory, topology, functional analysis, and fuzzy theory. Dr. Karpaya sir has presented and published extensively with multiple international and national research papers and 3 authored books such as Probability and Statistics for Modern Researchers and Mathematical Perspectives on Security and Portfolio Management. Our professor's academic excellence has been recognized through numerous awards and honors. He secured 4th rank in the Tamil Nadu TRB examination for direct requirement of assistant professors and received full sponsorship from the National Board for Higher Mathematics to present his work at the prestigious ICIAM 2015 conference in Beijing, and has been a UGC BSR research fellow. He is firm believer in continuous learning and professional growth, having successfully completed 54 NPTEL online courses and earned NPTEL Discipline Star and Domain Scholar. NPTEL Discipline Star and Domain Scholar in Algebra, along with several other recognitions for his commitment to lifelong education. As a passionate teacher and mentor, Dr. Karpaya sir has served as a resource person for more than 40 invited talks, workshops, and training programs across India. He has guided faculty members and students alike in topics such as differential equations, linear algebra, real and complex analysis, and especially he has coached aspirants for UGC CSIR NET, GATE, and other competitive education. His lectures are celebrated for their clarity, depth, and ability to spark curiosity and enthusiasm for mathematics. Dr. Karpaya sir is an active member of professional societies including the Indian Mathematical Society and the Indian Society of Industrial and Applied Mathematics, and he serves on the editorial board of the International Journal of Research in Applied, Natural and Social Sciences. He also keeps pace with modern technology, being skilled in LaTeX, MATLAB, Mathematica, and Python programming, frequently participates in international workshops on machine learning and artificial intelligence applications in mathematics. Dr. Karpaya sir's career is a true testament to his dedication to the advancement of mathematics and to inspiring both students and faculty to explore new frontiers of knowledge. So please join me in extending a warm and hearty welcome to our chief guest, Dr. Karpaya Kannappan sir, and in working forward to the insights and inspiration he will share with us today. We are very happy to be here, sir. Sir, the virtual platform is yours.
Thank you, ma'am. Thank you.
Thank you, Nandini ma'am, for the warm words of welcome and for presenting the profile of today's eminent speaker. We are indeed privileged to have with us Dr. Karpaya Kannappan sir, an expert in the field of mathematics, who will be sharing his insights on the applications of differential equations. I request Dr. Karpaya Kannappan sir to take the session forward and share his valuable insights on applications of differential equations. Sir, we are honored to have you with us. The session is yours, sir.
Thank you, ma'am. Thank you. Good evening to all. Thank you very much for inviting me this session. So my topic is applications of differential equations. Okay. So my screen is visible to all?
Yes, sir. Yes, sir. Visible, sir.
Thank you. So before going to application of differential equation, sometime I want to give some about some things about differential equations. Okay. First, I want to ask one question to all. We know the equation of circle. So what is the equation of circle, sir? Suppose some students ask you, what is equation of circle? We will say x square plus y square equal to a square. circle. Okay, parabola means
Y square equal to 4ax.
y square equal to 4x. Sometimes x square equal to 4ay. Okay, next ellipse. Ellipse means x square by a square plus
Plus
y square by
b
b
square.
square equal to 1. Okay. Now, my question is, what is equation of square? What is equation of square? What is the equation of square? So, answer is no. Because we not study any equation for square. Okay. What is the reason, sir? Because circle, parabola, ellipse, uh, these are smooth curves, sir. Smooth curve. Okay, smooth. That is no sudden changes like that. No vertex. Okay. So these are all smooth curves. But the shape of the square, the shape of the square is like that. So if we draw the shape of the square, we start here. If we start here, this goes like that. And in this point, it has sudden changes. Sudden changes. So sudden changes mean not smooth. Not smooth. Okay. So this is not smooth means this is not differentiable. Not smooth means not differentiable. Okay. So what? So only this is not smooth. So only it has no equations. Okay. No. So no equation. So like that, for example, we know one well-known function. What is mod x? So mod x is continuous function. Continuous function, but not differentiable. Not differentiable because when we draw the graph of the mod x, it is like this. It is like that. So when we draw the graph of the mod function, it is a continuous function because we can draw the graph the function without taking hand. Okay, okay, but at the point x equal to 0, at the point x equal to 0, it is not smooth. Not smooth. So only it is continuous function, but not differential function. Okay, so this is a concept of differentiable. Differentiable means it is called this smoothness. Okay, now I come to differential equation. Differential equation. What is differential equation? It is an equation. It is an equation which contains independent variable, dependent variable, and its derivatives. For example, dy by dx plus y equal to 0, it is a differential equation where y is a function of x. So x is independent variable, y is dependent variable, and dy by dx is derivative. Okay. So next. Now, What are the types of differential equations? What is types of differential equations? Generally, we know two types. One is ordinary differential equation. Another one is, the next one is partial differential equation. Generally, differential equation means it denotes only, in generally, it denotes ordinary differential equation. Okay, some other types are available, fractional differential equations, and most some of the differential equations are available, but mainly we focus only ordinary differential equation and partial differential equation. Currently, fractional differential equations. Okay. Next, what are types of problems? One is initial value problem in differential in ODE. Initial value problem. Next one is boundary value problem. Boundary value problem. So what is the difference between initial value problem and boundary value problem? First, suppose I have a second order ODE. For example, AY double dash plus BY dash plus CY equal to 0. So its general solution is given by y equal to some constant to y1 of x plus some constant to y2 of x, where y1 and y2 are two linearly independent solutions for this ODE, where y1 and y2 are two linearly independent solutions for 1. Okay. So when we have to find particular solution. Particular solution, we want to find A and B value, because A and B are some arbitrary constants. They can take any value. Okay, if we suppose substitute some particular values, it is called a particular solution. So we have to find the values of A and B. We need two conditions. We need two conditions to find A and B. We need two conditions. The conditions may be of the form type 1, like that y of A equal to some value and y dash of A equal to some value. Or type 2, y of A equal to some value and y of B is equal to some value. Okay, so to find the values of A and B, we need two conditions. The conditions may be of the type 1 or of the type of the form type 2. So what are the difference between these two types? In first type, we given all conditions at a single point. That is, we know the starting value only, but we don't know what about the ending value. But in type 2, the conditions are given at two different points. That is, first point is given at A and the second condition is given at the point B. So in type 2, we know the initial point and the ending point. Okay, so this type of problem, using these concepts, the first time we know only the starting value. Starting value means it's the initial point. So this is called the initial condition. Initial condition. The second one is called boundary conditions. So suppose the differential equation given by using initial condition means it is called initial value problem. Boundary conditions means it is called a boundary value problem. Okay. So that is initial value problem means in the differential equation, all conditions are given at a single point. Single point. So this is called initial value problem. Suppose the conditions are given at more than one point, the problem is called a boundary value problem in ordinary differential equations. Okay. Next, eigenvalue problem. Eigenvalue problem. What is meant by eigenvalue problem? We know the concept in linear algebra. We learned the concept in linear algebras. Okay, what is eigenvalue problem? Eigenvalue problem. So first I explain the eigenvalue problem in linear algebra. Linear algebra. Okay. In linear algebra, we take let x be a non-zero, very important, non-zero unknown vector. Unknown vector. Vector means in generally denoted as column matrix. Column matrix. That is n by 1 matrix. I take. So I take x be a non-zero unknown vector. Vector means a generally column matrix in algebra, in linear algebra. Okay. Next, I take let A be a n by n matrix. N by n matrix. Okay. Now I will operate A with x. Okay, which gives again x. Okay, we will multiply A with x. It gives again x with constant multiple lambda. Okay, so this problem is called eigenvalue problem, where lambda is called eigenvalue. Eigenvalue, x is called eigenvector. So this is called eigenvalue problem. So this is called eigenvalue problems. Okay, what are the concepts are there here? First one, it is a homogeneous system. First one, we know well, Ax equal to lambda x is a homogeneous system. Homogeneous system. Homogeneous system means x equal 0 is always a solution. X equal 0 is always a trivial solution. So always a trivial solution. Okay, but our assumption is x be a non-zero unknown vector. Non-zero vector. So our aim is here, our aim is to find lambda, which gives non-zero solution. Non-zero solutions. that is x. So our aim is to find lambda which gives non-zero solution. So only, so therefore eigenvalue means which lambda gives non-zero solution. Non-zero solution. That lambda is called eigenvalue. Okay, it is very important. So eigenvalue means we say all the values as eigenvalue. Only which lambda gives non-zero solution, that lambda is only called eigenvalue. Okay. So I give one simple idea about homogeneous system. Homogeneous. Okay. So suppose, so I give ask one question: is dy by dx plus x equal to 0 is homogeneous? So answer is yes or no. It is homogeneous equation or non-homogeneous equation?
Homogeneous, sir.
Is it? Okay, I will ask and I will give one more question. Okay, say that suppose dy by dx plus y equal to 0 is homogeneous. Yes or no, sir? Is homogeneous? Second one is homogeneous or not homogeneous? Okay, so actually this is yes. The second one is homogeneous equation. But first one is no. First one is non-homogeneous equations. Because we say why we say it is homogeneous means sorry, just a minute. What is homogeneous definitions? Homogeneous definition means like that. L of y dash, y double dash plus etc. which is equal to function of x. When we write the differential equation in this form, if f of x equal to 0 is called homogeneous equation. F of x is not equal to 0 means it is non-homogeneous equation. Non-homogeneous equation. So when suppose we have to find homogeneous or not, first we write the given differential equation in this form. Then only right hand side 0 means it is homogeneous equation, otherwise non-homogeneous equation. In first equation, I give dy by dx plus x equal to 0. It is not in the form because in left hand side only y and the derivative terms only available. The x remaining are we come to right hand side. So write this equation in this form dy by dx which is equal to minus x. So here right hand side is not equal to 0. So it is non-homogeneous equation. Non-homogeneous equation. Okay. But I give a simple idea how to find non-homogeneous equation. For one more example, before is suppose the equation is dy by dx plus sine of x plus y equal to sin x. Homogeneous, yes or no? So here, right hand side is equal to sin x. So not equal to 0. So it is non-homogeneous. Means it is wrong. It is wrong. Because when we ask the equation is homogeneous or non-homogeneous, we must write the given differential equation in this form. L of y, y dash, y double dash, etc., which is equal to f of x. Then only right hand side 0 means homogeneous or not, otherwise non-homogeneous. So first we write the equation in this form, L of y equal to f of x. How will write, sir? So first expand dy by dx plus sin theta means theta minus theta cube by 3 factorial plus theta power 5 by 5 factorial, etc. So like that. So sin of x plus y means x plus y minus x plus y the whole cube by 3 factorial plus x plus y whole power 5 by 5 factorial minus etc., which is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus etc. Then when we see here x cancel, here we have x cube by 3 factorial minus 10. So this cancel. Similarly, all the terms in right hand side are cancels. So then we have like that dy by dx plus function of y equal to 0. So now this right hand side is 0, so it is homogeneous equation. Homogeneous equation. Okay. So I give some hint for you to find homogeneous or non-homogeneous. Simple idea. Hint to find homogeneous or not. Very simple. Let okay, sorry. How to find homogeneous or not? I give simple hint for you for competitive exams. If y equal 0 is trivial solution for differential equation, then the equation is homogeneous. So no need to write the given equation in this form, L of y equal to f of x. There is no need. Just check y equal 0 is a trivial solution for the ODE. If yes means it is homogeneous, otherwise non-homogeneous. For the first example, verify the first example. What is the first example? Dy by dx plus x equal to 0. Let y equal to 0. So which means dy by dx is also 0. So here left hand side is 0 plus x, which is equal to x. What about right hand side? Which is equal to 0. So LHS is not equal to RHS. Therefore, y equal 0 is not solution. Therefore, non-homogeneous. Answer. What about second example? So dy by dx plus sine of x plus y, which is equal to sine y. So let y equal to 0, which implies dy by dx equal to 0. So what about left hand side, which is equal to dy by dx 0, y equal 0 means we have sine x. Sorry. X. Okay. So what about right hand side, which is also sine x. So let left hand side is equal to right hand side. Therefore, y equal 0 is solution. Therefore, it is homogeneous equation. So answer is very simple. Okay. So I give some idea. Okay. Okay. Now I come to my topic. What is a what is it called? Eigenvalue problem. Okay. In differential equation, what is eigenvalue problem? In differential equation, eigenvalue problem means let y be a non-zero unknown function we operate d square by dx square on y, which gives again y with the constant multiple mu. So this problem is called a eigenvalue problem, but we rewrite the equation in our general form. That is, our general form means L of y equal to f of x. This is our general format of differential equation. So we rewrite this differential equation like that: d square y by dx square minus mu y equal to 0. We remove the minus sign. So d square y by dx square plus lambda y equal to 0. So this problem is called a eigenvalue problem, where lambda is called a eigenvalue and the corresponding y is called a eigenfunction. So lambda is eigenvalue and y is eigenfunction. Okay. So now I come to our important problem called Sturm-Liouville problem. Sturm-Liouville problem is nothing but combination of eigenvalue problem and boundary value problem, which is Sturm-Liouville problem combination. Because in eigenvalue problem we use differential equation, in boundary value problem we use boundary conditions. Okay, so combination eigenvalue problem and boundary value problem is called Sturm-Liouville problem. For example, question is find eigenvalues and eigen functions of d square y by dx square plus lambda y equal to 0, y of 0 equal to y of L equal to 0. This problem is called a Sturm-Liouville problem. Okay, one thing is must, that is we say all the lambda has eigenvalue. The eigenvalue means which lambda gives non-zero solution, because eigenvalue problem is always homogeneous equation. homogeneous equation always have trivial solution y equal to 0. But in our assumption, we take y is non-zero unknown function. So our aim is we have to find non-zero solution for this problem. So when which lambda gives non-zero solution, that lambda is called an eigenvalue. This is called a Sturm-Liouville problem. Okay. Next, these are some concepts about differential equations. Now I come to some applications. Main applications used in electric circuit. Electric circuit theory. Mainly we use differential equations in electric circuit theory. What is electric? In circuit theory, in physics, we learn some terms. What are the terms? First one is resistance. Resistance. What is the unit? Ohm. Symbol is this. Okay. Next is inductance. Capacitor. Sorry for this. So what are the terms we know in studied in school level in physics? We know the term resistance. This unit is ohm. Next is inductance. It is denoted as L. Resistance is denoted as R. What is the symbol for resistance? It is like that. This is resistance. Inductance is given by this. Okay. And capacitor. Capacitor is noted as C. The notation is like that. And one more, the main is voltage. Voltage. Voltage is given by like that. Okay. What are the units? Resistance is given by ohm. Inductance is the unit is, we know, I think Henry, like Henry. And capacitors, Farad units. And voltage means volt. Okay. This is a, in electric circuit we study these terms. So first simple circuit is I think LC circuit. Take LC circuit. L is inductance. L capacitor. Okay. So I take a simple circuit like that. Okay. Here only two terms. One is capacitor and another one is inductance. So this is called LC circuit, simple circuit. Okay. For this circuit, what is the differential equation? If I take QB charge, QB charge on the plate and IB current, let IB current in the circuit at time t. At time t. Okay. We know some terms. We know the one law, Kirchhoff's voltage law. Kirchhoff's voltage law. What's the sum of voltages is equal to 0. Sum of voltages is equal to 0. This is Kirchhoff's voltage law. Voltage law. There are two laws in Kirchhoff's. One is voltage law, one is the current law. Okay. So we need to define C and L in terms of voltage for this circuit. Okay. So we know the results. The voltage across C is given by Q by B, Q by C, sorry, Q by C, because V equal to Q by C. That is Q equal to CV. Q equal to CV. Okay. Next L. So voltage across L is given by L into di by dt. Okay. Now, using Kirchhoff's law, what is the equation for this? Sum of voltages equal to 0. So what about C? What about L? L means the voltage is L into di by dt plus in C. In C, the voltage is given by Q by C. Q by C, which is equal to 0. This is our required differential equation. But here, what is the independent variables? Independent variable is nothing but t. Independent variable is t. What about dependent variable? Dependent variable is q, sir. What? Q. Here, dependent variable is q. Okay. So current is given by I equal to tq by dt. So we can change this equation like that. L equal to t square q by dt square plus q by c equal to 0. This is our required differential equation for LC circuit. Okay, it is a homogeneous equation, second order equation, constant with a constant coefficient. We can solve the equation using well-known concepts, using auxiliary equation like that. Okay, one more circuit. Next circuit is LRC circuit. LRC circuit. What is LRC? L means inductance, R means resistance, C means capacitor. Okay. So but now we got right equation. What is the diagram for the circuit? Capacitor, inductance, resistance. I give some voltage. Okay, this capacitor, resistance, and inductance. So now we saw equation. So first, using Kirchhoff's voltage law, we rearrange the terms C, R, L in terms of voltage. So for C, voltage is given by Q by C. For L, voltage is given by L into di by dt. In R, we know the formula Ri. Ri. So we studied V equal to IR. Okay, so using Kirchhoff's law, now we write the equation sum of voltages equal to 0. So what about L sum? L means L into di by dt plus for C Q by C plus for R Ri, so which is equal to EF. Third differential equation for L. So now we can change the equation in second order because Q is dependent variable and T is independent variable. So we change this equation L into d square Q by dt square plus Q by C plus R into dq by dt equal to EF. So similarly, we can write for circuits equations for different types of circuits. Okay. So next, in PD, first, okay. Types of solutions. Before I go to I give some simple differences between ODE and PD. ODE and PD. Okay. First, formation of ODE. Here, formation of PD. Okay. Formation of ODE means, example, we can find ODE from given equation containing constants. By eliminating the constants. Eliminating constants. Okay. For example, suppose y equal to mx means where m is differential equation is given. Okay. The constant m, we have to find the differential equation. So how many here? How many arbitrary constants are? Only one constant. Only one constant. So we need only one condition to remove the arbitrary constant m. Enough. Only one constant is enough. That is, first derivative is enough to remove the m. So then, what is dy by dx? Dy by dx equal to m. So which implies y equal to dy by dx into x. This is our required equation. Okay. But similarly, suppose y equal to mx plus c means here there are two constants. So to remove m and c, we need two conditions. So that is, we need up to second order derivative. Okay, we need up to second order derivatives. So first derivative means dy by dx equal to m. Second derivative means d square y by dx square equal to 0. So this is our differential equations. Enough. Okay. So in formation of ODE, by eliminating arbitrary constants, we find the differential equations. But in PDE, there are two concepts. One is by eliminating arbitrary constants. Another one is by eliminating arbitrary functions. So using the two different types, we have find the PDE. Okay. Now I come to types of solutions. So given differential equation means the solution is given by of the form y equal to function of x comma c. So using arbitrary constants. But in PDE, solutions is given by in two types. For example, one is using function of x comma y comma a comma b constants, one type. Another one is using functions z equal to function of u comma b, u comma b. Okay. So in ODE, only one type of solution, but in PDE we have find two types of solutions. Okay, the solutions is denoted as in ODE it is also general solution, complete solution. Both are same in ODE, but in PDE using arbitrary constants, it is said to by general solution. But using arbitrary constant is denoted as complete solution. Okay. So in ODE, general solution, complete solution are same. But in PDE, complete solution is different, general solution is different. Complete solution is given by using arbitrary constant. General solution is given by using arbitrary functions. Okay. So this is a difference between one of the difference between ODE and PD. And the second difference means for solving ODE, we have some specific methods. Specific method means it gives, in using any method, it gives one particular solution, one type of solution. But in PDE, we have different methods. lot of methods. Chart-pit method, mongoose method, Fourier series method, and the simple method. There are a lot of methods. So it gives different types of solutions. So one of the main difference between ODPD is this. Again I say ODE have some particular method to solve the differential equation. So it gives some particular type of solution for format. But in PDE, it has no general method to solve the PDE. It has lot of methods. So each method gives different types of solution. One method gives complete solution. One method gives general solution. One method gives particular solution, like that. Okay, is one of the difference between and ODE and PDE. Okay. Okay, so I think, so any doubt? So in ODE and differentiation, lot of concepts available. I give some simple ideas only. In future, I will give each topic, if possible, clearly to all.
Thank you, sir. Nice explanation, sir.
Thank you, sir. We will now begin the discussion session. If any participants have questions, kindly ask directly or type them in the chat box. Sir will rectify. Any questions? Pushpa, ma'am?
Ma'am, there is one question, ma'am.
Yes.
What is the difference between differential equation and difference equation? Sir?
Now unmute, ma'am.
So differential equation means it is a function. The solution is a function. Okay. But in differential equation is also denoted as recurrence relation. Differential equations is also called recurrence relation. So recurrence relation means it is a sequence. The answers are given by some sequence. Okay. For example, we know the Fibonacci sequence. Fibonacci sequence means, I think, you know well about Fibonacci sequence. Well-known example for Fibonacci sequence is 1, 1, 2, sorry, 0, 1, 1, 2, 3, 5, 8, 13, etc. So what is the meaning? General format is this sequence is given by some type of equation, like that yn is given by nth term is given by sum of previous term per previous 2 times. Okay, here y0 is 1, y0 equals 0, and y1 is 1. Okay, so what is the format? First term, 2 terms are defined, 0 and 1. The remaining terms are given by sum of 2 previous terms. So this 1 is given by sum of 2 terms. The 2 is given by sum of 2 terms. 3 is given by sum of 2 terms. Okay, this is called a difference equation. Is also called a recurrence relation. Okay, so here is a function. Here solution is given by nth term of the sequence. But in differential equation means differential equation, it is, if a solution is given by, is a function, is a curve. Okay, sir? Okay, ma'am?
Okay, sir. One more person, Dr. Braknesh Kumar, raised the question. Kindly suggest some books containing application of differential equations, sir.
Ma'am, I will give, send to you. You can forward, ma'am.
Yeah, sure, sir.
I
Thank you.
can say no.
Thank you, sir. Participants, any questions?
Now unmute only.
There is no question, sir. So one more question. P. Deepa asking, difference equation is discrete values and differential equations is continuous variable, sir. Is it correct, sir? Pushpa, ma'am?
Yes, ma'am.
Audible, ma'am? Am I audible?
Yes, ma'am.
Yes, ma'am. Audible.
Yes, ma'am.
Sir,
Difference equation, it gives, the solution is given by nth term, is a particular value. Okay, so maybe 100 term, 1000 term, like that. But in differential equation, it is a function. So function means it's a continuous function. Maybe in differential equation means it's a continuous function.
right, okay.
That's right.
Okay, sir. Thank you. There is no more questions here. Okay. Now, as we move towards the conclusion of today's session, I request Dr. Subhadra ma'am to propose the vote of thanks.
Thank you, ma'am. Good evening to one and all. Mathematics is the bridge between the theory and practice, and the differential equations stand as cornerstone in transforming abstract ideas into real-world applications. It is indeed an honor for me to propose the vote of thanks on behalf of the Department of Mathematics, New Prince Sri Bhavani College of Engineering and Technology. At the outset, I extend our profound gratitude to Dr. Karpaya Kannappan, Assistant Professor, Department of Mathematics, Government College of Engineering, Bodinaikanur, for delivering today's insightful lecture on the applications of differential equations. Sir, your lucid presentation on scholarly exposition have significantly enriched our knowledge and broadened our perspectives on the real-world relevance of mathematics. We convey our sincere appreciation to our respected Chairman K. Loganathan, Vice Chairman L. Naveen Prasad, Director Professor A. Swaminathan, to our Principal Dr. T. Saravanan for his constant encouragement and unfailing support in organizing this faculty development program. Our heartfelt thanks to Dr. S. Sivagami, Head of the Department of Science and Humanities, for their invaluable guidance and motivation. I would also like to place on record our appreciation for Dr. G. Pushpalakshmi, FDP Coordinator, for her commitment and meticulous effort in ensuring the success of this event. Last but not least, I extend our gratitude to all the distinguished participants who have joined us today. Your active encouragement and presence have greatly contributed to the success of this FDP. Once again, thank you all, and we look forward to meeting tomorrow with renewed excitement. Thank you, ma'am.
Thank you, Subhadra ma'am, for your kind words of gratitude. Thank you very much, Dr. Karpaya sir, for your insightful and thought-provoking lecture on applications of differential equations. With this, we come to the end of day 4 of our FDP program. We extend our heartfelt thanks to our esteemed resource person, participants, and organizing committee for making today's session a meaningful one. We look forward to your enthusiastic participation in day 5 of this FDP. Thank you all. Thank you very much, sir. Thank you.
Thank you.
Thank you, sir.
So,
Thank you, sir.
it's a photo session.
Photo session.
Kindly please on your feet.
Bhadra ma'am, take it, ma'am.
Ah, yes, ma'am. I do it, ma'am. Done, ma'am.
Thank you, ma'am. Thank you all. Thank you.
Okay, thank you all. Please leave it.